Hi, I'm Holly McLean for TrainLi Tech TV, and welcome back to episode 2 of building the Kleine Scheidegg train station. Now in episode 1 we went ahead and covered a little bit of background on that train station, how we discovered it, and how we got the rough dimensions of walking it off the length and width, and taking lots of pictures of the building, and especially pictures of some of the detail that we wanted to include in building this model. I started out on doing these buildings by actually just drawing them out and using just a square and a straight edge and pencil and ruler, and started cutting the materials, and that worked fairly well for fairly simple, straightforward buildings and structures. But as our desire to have more complex buildings with different roof lines and different sides and shapes on the building, and not just your square kind of block house, it became important that we had very accurate cuttings and drawings of these buildings to make sure, especially we want to make these as pretty weather tight or weather resistant as possible. So having really good solid joints that match up perfectly, and when you have a complex roof with lots of different angles, making sure that those are all perfect are really important. So we kind of looked into doing some CAD drawings, and there was a company here in town that does a lot of manufacturing and CAD drawings and so forth. Then went to them and had them do some of the initial CAD drawings on a couple of our buildings. They did a great job, but there's a lot of kind of R&D in designing these buildings. There's no owner's manual or instructions, so you just kind of have to work your way through it and figure out the best way to draw them and assemble them. And it was taking several hours to accomplish this, and their rates were pretty expensive for just a modeling application. So I talked with them, and they had referred me to a student that they knew that was going to the engineering school at the University of Nevada, Reno. By the way, that's a great university. And they met with this young kid. His name was Nico, and he was originally from the Bay Area and moved up here to go to the school at the university. And he had also had some background in building models. He liked to build model airplanes and so forth. So having a little bit of a background on how things go together and fit and work, I think was definitely an advantage, as he could understand, grasp quickly on how the buildings needed to go together, and then once they're together, to be able to have sections of them come apart so that we can adjust fixed wiring or anything inside those and do routine maintenance. So we ended up meeting with Nico, and he ended up working on several of our buildings and drawing those out, and it worked really well. And the accumulation of knowledge on how we want these to fit together worked well. And we actually then ended up working at TrainLi for almost a year or two, and probably some of you may have talked to him on the phone. He was one of our head technical guys there on doing installations and electronics and so forth. But eventually he graduated from the University of Nevada, Reno, and got accepted to a school in Paris, actually just outside of Paris, to get his master's. And now with the internet and everything, it was quite simple for us to continue working with Nico. He, like I said, is going to school right outside of Paris. And what I'll do is after taking all the pictures, I will send those pictures to him either via email or put them in a Dropbox, and describe what the building is and how we kind of want it to look, and the rough dimensions that I had done while taking the pictures and visiting the actual location. He will then take it from there and start laying out the building. So What I'd like to do now is introduce you to Nico, and we're going to be doing a Zoom meeting with him. I'll be here in Reno, and he will be there in just outside of Paris. It's early evening there. It's about 10 o'clock in the morning when we did this interview with him, and I'm happy to introduce you to Nico. Well, hello again, and I'm Holly McLean for TrainLi Tech TV, and today we're going to be talking to Nico and the next step of how to build the Kleine Scheidegg station. If you remember our last episode, we just kind of talked about the theme and that we took a lot of pictures. We walked off around the building to get some rough dimensions, and then what I do is I send these over to Nico, and I'm here in Reno, Nevada, and Nico's looks like it's a wonderful afternoon, evening outside. You're in Paris, France, aren't you?
Yep, I'm just outside of Paris.
Just outside of Paris, okay. So these buildings are kind of like I was just thinking about, it's really kind of cool. We're building a building from Switzerland that then I start the rough designs, and then to Reno, and then it goes to you in Paris, outside of Paris, and then from Paris back to Arizona, and then Arizona back to Reno. So it kind of bounces all over the world to get these buildings done. Certainly wouldn't have been able to do that a few years ago, but you and I have been doing buildings for several years now, and lots of other projects, and you were actually one of the techs at TrainLi for, I don't know, were you there? How long were you there for? About a year or so?
2 years.
And we originally met, you were a student at the University of Nevada, Reno. Got to give a plug for UNR, and you were in the engineering school?
Yep, doing mechanical engineering.
Mechanical engineering, and you're originally from the Bay Area. And then you went to school at UNR and got your degree there. You did get a degree, actually.
I did get a degree.
Okay, you were one of the lucky ones that got to have a real graduation.
Yeah.
And then you got accepted into where's the school that you're going to now?
I'm going to École Polytechnique, so the Polytechnic University of Paris, and that's just outside of Paris as well. It's a really old school, and doing a master's in Internet of Things, Innovation, and Management.
Excellent. So we're good. We do. So I find a building that I would like to replicate, and I take a bunch of pictures, and I send them off to you and say, hey, Nico, this is our next project. And it's roughly, I think I said it was roughly like 140 feet long and about 20 feet wide, and 3 stories tall. And how do you go from there? What's the next step?
So the first step is trying to get an idea of what this building looks like from all sides, so that I can build the base plate. And the base plate is going to be sitting on the ground and really holding all of the walls together. So I like to draw the outline first, and that requires looking at really just all sides of the building and getting an idea of what that building looks like.
And you have, we've kind of evolved over the years on working on these different buildings, on how to build them, and we have to kind of think 3 or 4 steps ahead for down the road. Once they're completed, how do we actually access the inside, or how do they actually go together?
Well, I think it gets more and more fun as we go further and further into the complexity. And there are certainly new challenges with every building. One of the challenging things that I found has been increasing is the roof complexity, because building walls is relatively easy, but making sure the roofs mate correctly and we can build this in 3D from 2D parts is always a fun challenge. So I started using a student version of software that's very expensive and difficult to get a license of. And I was able to use that as a student, but nowadays I use Autodesk Fusion 360 suite, and that's free for anybody for hobby purposes, which is what we're doing, and really easy to learn. There are great tutorials online, and it's a full suite, so you can go from taking a picture and dropping a picture in there and saying this part is this size, and then building from there, making 3D parts, making collections of parts, and even 3D printing if you want to.
So now you start out with this base plate, and I think you said that this is going to be in 1-to-1 scale about 7 feet long and about 2 feet wide.
Right.
So, but this one is a pretty straightforward, simple build, right? We only have a few pieces. What do we end up with? Like over 200 pieces on?
I think over 200 pieces, yeah.
Right.
I know there are over 125 unique parts.
So
a lot of those are copied again to create the building.
The whole idea of this is to have a very solid structure that can hold up to wind and rain and snow and heat and cold and all that stuff, that then we apply all the detail.
After I've drawn the outline on the base plate, one of the first things that I do is I go ahead and set my material properties. So I know that I'll be using 3 different thicknesses. So as you said, the base plate is the thickest part, put that as a 1/2 inch thick. And then I go for 1/4 inch thickness on walls and roofs, and then 1/8 inch thickness on anything that's going to be aesthetics or needs to be seen from the side and needs to be that thickness. And with that, with these material properties set and the outline on the base plate, I start by just drawing the little tabs that you're going to use to assemble them. The goal when I'm building is to make it all like a big puzzle for you without any instructions.
Yes, and that's exactly how it shows up.
And so I start by building this base plate with tabs, and then I'm going to mark off what sections of walls are going to be where. So on this building, we have, I believe, 4 different sections that I call, in my drawings, wall A, B, C, and D. And I then go ahead and start just drawing tall walls, not paying too much attention to the height, but more paying attention to the silhouette and the shape, and making sure that these all fit together like puzzle pieces. And once I get all those walls done, once I get all those walls built, then I'll go ahead and trim off the top to make sure they all line up like in the drawing. And then I move on to the roof, making sure that the roof is removable so that you can get in there and fix any electrical problems you might have, or install some seasonal characters in your little restaurant. And once the roof is all set up, then I can move on to the windows and little accessories.
And with this building, it was certainly a lot more complicated because we had, most of the other buildings we just had pretty much a single kind of roof line. And this one has 2 or 3 different levels. And we actually put inside the building a second floor, which that wasn't too complicated, but I imagine the most complicated part was going around the front where the gift shop is and getting all those pieces to line up. And
yeah, the gift shop was very complex, and comes back to my point on making a 3D object out of 2D shapes. Becomes very tricky. From my perspective, I can zoom in infinitely and see very small details where, as a builder, you might not think, there's no interference on your build, and maybe there's a 0.1 degree angle that you won't notice, but I can see it. and I have to make sure not to spend too much time on those little details and make sure the bigger picture looks good.
Typically, about how many hours you had in drawing out the Kleine Scheidegg?
I think it was about a full day, or I think it was 24 or 27 hours, something like
I
that.
thought it was close to about 30 hours we had into drawing
Yeah.
that up. The next step is called nesting. Once we've kind of said, we got all of our pieces, and what is nesting?
So when I build this, when I do the CAD drawing, it's in a 3D model in a 3D environment that I can move parts around in. But the parts are cut out of a single sheet or a series of sheets of plastic, and I need to transform these 3D parts into 2D shapes. So that means going around the entire building and slowly taking the silhouette of each part and then eliminating that one off the drawing. And while I'm doing that, I need to make sure that I keep track of how many of that part I have in the drawing, so that I don't spend too much time taking the same silhouette over and over again, for example. And once I have all of these silhouettes, then I go into another program. This one's called NanoCAD, and it's another free, this time a two-dimensional CAD program, where I draw a big rectangle and put all of the parts nested, as we call it, in this big rectangle in a way that reduces the material waste to a maximum. And we and I have to leave a certain thickness between all parts to make sure that there's no overlap, and the workers who are pulling these parts off of the machine are able to pick them out.
So does that program actually nest them, or are you actually nesting them all together?
I am doing that one by hand. So I import all of those individual profiles into the program, and I move them around and try to find the best orientation. I turn things around and I flip them sideways and make sure everything is all nested together.
If I wanted to find another Nico, where would I go look?
Well, I can't tell you everything about that, or else you'll go find another Nico. To start, I would definitely look at the university in your area. Like you found me through an acquaintance that worked at a plastic cutting company, and I had a class with him, so he asked me if I was interested in this. So word of mouth at a university. If you have a contact there, then if it's a professor, maybe putting out a notice on their classroom bulletin board or something like that.
Is it just as simple as saying, "Hey, I need a kid that is good with CAD drawings," or is there something more specific that I should be asking for?
I think CAD drawings and experience with 3D models or something like that. I grew up building model airplanes, so I have a pretty good understanding of how things fit together like a puzzle. And I think that helped me a lot in starting to design buildings for you.
There's also like a job site, job posting board or something like that that you can talk to and get those posted as well.
I think that a lot of students are looking for a little side work like that.
Yep.
And I was very happy to spend a couple hours a week on drawings for Holly. That was a lot of fun for me. Like the materials that you use, that was hugely helpful when I learned that you were using plaster for certain sides, and I could leave a little bit of thickness off of that side, for example. I think the gift shop is going to be certainly a challenge. Because it's round and made of very thin parts, a lot of very thin parts, I think that it'll be a challenge to, first of all, not break any of them. And after that, to make sure all the angles work out just right. I tried to leave as many construction pieces in there so that you have good references on the top and on the bottom. but the awning going around the rotunda is nearly unsupported, and that's going to be exciting. Sure, so this is the base plate that I start with, and this is the sketch that this base plate is built off of. Sketches are drawings that then get extruded into three-dimensional shapes. And so here we can see I've just got the outline lined out, and I've given a little bit of space for the awning here, just to make sure that the awning isn't too much on the edge. So once I have that outline, I add the holes for the pins, the slots for the pins or tabs, and then I go ahead and extrude that to create the base plate. And from there, I get the walls. So here I'll activate all of the walls. So once I have the base plate, I go ahead and add the walls. And one important thing in my building organization is to keep the different components compartmentalized into component groups. So here I have all of the walls, so I can turn those on or off. So here at the end, I ended up building this entire building backwards, and then went ahead and mirrored the entire thing on one of these ends here to make it the right way over. So as you can see, the walls are each individual two-dimensional pieces, and they're all 1/4 inch thick PVC with the windows cut out. The windows are one of the last things that I do. I try to just leave everything blank until I have a specification on which windows we'll be using. So once I have those walls figured out, I move on to the roof. And here on the roof, so as I mentioned previously, I separate it into A, B, C, and we can call D as the rotunda or the gift shop. And on the roof, I have roof A, B, C, and D underneath here. So if we just go to roof A alone, here. So I start with this base plate, and then create some geometry. Let me turn those on. So I create these geometry planes to have a reference to work from. Then I start building the wall on the back, everything that's going to be fit into there. And I try to use as much symmetry as possible as is afforded by the shape of the building. Slowly inching along until, so here what I was building is the bottom ring that's going to make it fit into the gift shop. And then now we're working on the top. So we have these wedges that are going to be holding the roof up. And then the wedges of the roof itself. Continuing along there. Then I'm going to do a circular pattern around the roof, around the axes of the roof that I defined. And once I have half the roof, I go ahead and use symmetry to finish it off.
That's pretty cool.
And so that was a really difficult roof because I've never made a round roof like that. A more classical roof is, well, this one's still not quite classical because of this cross section here. But I start again by defining geometry, and let's get that geometry shown. There we go. So I always find the mid planes of the roof, and I create one side. Again, I'm just going to create one side of this entire roof, and then I'm going to mirror it over. One side, and then I'm going to mirror it over. Again. And so here I start with the bottom roof. Either one could technically go on the bottom, but because this one is smaller, I thought it would be more structurally sound if this one stayed in one piece, and a bit easier to build for me. So once I have that section, I can cut out these little other parts. And earlier when I mentioned zooming in infinitely and seeing every little problem, here we can really see these might have a 1,000th or 2,000th of an inch overlap, but that's not going to be a problem for Holly building it. Here I create supports for inside of the roof and mirror that over. And this is actually great instructions for Holly on how to build the thing. He's never gotten.
Helps. I have to watch my own how-to video on how to put this thing together.
And here, again, creating one side of the roof and using reference geometry. So this is the, how do they call it? The axes through two planes, and using that on my sketches to reference. And it's really a repeated process of draw one side and copy it over until you have a finished. And from there, I think you can imagine how I create these smaller roofs. Yeah. And here you can see, again, we have some components that are hidden underneath the other ones to create some structural integrity. Awning going around the rotunda is nearly unsupported, and that's going to be exciting.
Good. All right, well, Nico, thanks again for walking us through on how you do these CAD drawings of these buildings, and some of them are pretty straightforward and simple, like the little junction box, and then this Kleine Scheidegg. This is a big building, a big model, and a lot of pieces. I think you said over 125 pieces. So that will be a fun puzzle to put together. I imagine it'll take us a few months to get this thing put together. But thanks again.
Well, I hope you enjoyed our conversations with Nico there in Paris. I never would have thought that I would have been doing an international design build of model railroad buildings, but it's worked out quite well. And Nico and I have done quite a few beautiful buildings together, and I really appreciate all the work that Nico contributes to building these models. So our next episode, episode 3, is going to cover the next step of actually cutting this material out. And we're going to travel to Arizona, and they're going to walk us through all their different technology that they have for cutting all different types of materials, and also all different types of shapes, from 2-dimensional to 3-dimensional cutting. It's a pretty neat high-tech company, and that's where we send all of our files to get cut out, and then they ship everything back to Reno, and we start putting everything together. So we've gotten a lot of comments and questions off of our first episode of building the this model, and so continue doing that. If you have any questions or comments, please contact me via our YouTube channel, which is the Alpine and Western Pacific Railroad, or you can email me at TrainLi, and that's HAWLEY at trainli.com, and we look forward to those comments and questions and any suggestions that you have. I'm Holly McLean, and thanks again for watching.